Okay, so let's figure out what the majority element question states, right? What it states is that you're given an array and you're supposed to return the element that occurs greater than n by 2 number of times. Okay, so let's say you have an array of 1, 2, 2, 1, 3, and another 2, right? So what is the majority element here? The one that's occurring the most is 2, right? But is this a majority element? Let's see how many times it comes. Once, twice, thrice. How many total elements are there? There's 6. So it occurs exactly n by 2 times. So 2 is not the majority element over here because it has to be strictly greater than n by 2. This thing needs to be followed. Okay. First interesting constraint. Second thing is that you're supposed to assume that the number always exists, the majority element in whatever sample cases are given. So let's go ahead and solve this. First thing, the brute force would be to count each of these individually and check all of those values, correct? What I'm gonna do instead is and wait, the other method is obviously using the hashing. So you hash the element and the count, correct? Third thing is your Morse voting algorithm, which is the most optimal solution because your hashing will give you a bottleneck of n log n, correct? And you're trying to bring this to n, O of n complexity, so you have only one iteration over here. So how do we do this? What Moore's algorithm says is that it maintains two variables called count and current. Okay, what does it do? It first, let's just do a dry run of the algo first. Okay, what it does is it slowly iterates over the array. Every time it finds an element that matches your current value. So let's say current is 2 and your count is 1 when your I is here. What does the current count value become? Your count value increases to 2 and your current remains. Okay, now I moves over here. What happens now? It's not equal to the current value, the nums of I value, and so you decrease the count, correct? Your I moves again, you decrease the count and it reaches 0. Now why is this point important where it reaches 0? It's important because if, let's say, this was your final array and your count reached 0, then it means that whichever number you assumed was the majority element or whichever is the current element, it cannot be the majority element because it occurs exactly n by 2 number of times because its count got cancelled out, correct? So this is clearly not the majority element for this array. But now you might say, well, what happens to the remaining array? So let's just say that this was your array, correct? And it had one more number called 2, correct? So once this was crossed, your I would reach over here and the count would become 1 and your value would become 2. And so you would return 2 because your count is 1 and the end of your array is reached. You know? But now you might say, well, what if the number over here was something like 3? Well, in that case, there would be no greater element or majority element, and that is why the second assumption is very important. Correct? The fact that the array will always have a majority element. So now there is one other scenario that you need to be worried about over here, or you might think is going to make this thing fail. What if, okay, the first scenario we discussed is the ending. The second scenario we discussed is if there is another number. I don't think there's any other scenario to discuss. So let's just do a dry run of this. Let's see if it comes up over there. So your I was over here, your count becomes 0. You increment your I, correct? You increment your I, your current value now becomes 1 and your count becomes 1. Increment I, oh, it's 0 again. What does you do when it becomes 0? You change the current value and make it 2, correct? And then you increment. Obviously you make it 1, by the way, over here when this is the case. And then you increment and you reach 2 over here. What do? You increment it to 2. This remains the same. Your I reaches here, it becomes 0, it becomes 1, and then your I reaches here and it becomes, this was 1 at this step itself, right? And this becomes 0. So is there any majority element over here? No. Oh wait, your current element became 1, right? So your answer is going to be 2 over here. So your count answer is going to be 1 over here. I guess I've made a mistake, but you understand the algorithm at this point. So now, as you have reached this value and your current is equal to 1, you just return current, right? So let's just go ahead and check out the pseudocode of this thing. Now the pseudocode says you take a function called f, and you have a parameter called nums. You initialize these values like this, and you iterate until it does not exceed the size of the value. This is the first and most important constraint, and this is what breaks the loop. Well, not breaks the loop, but there's like a a significant portion, and there's the first thing that you need to check is if count becomes 0, which means that until this value, if this is your array and you're over here, then until this value, whichever element you have chosen, is that the majority element or it is not. If it is 0, then it means that this is not the majority element because it has come exactly n/2 number of times. What do you do in that scenario? You make this as the current value and you make the count equal to 1. And of course you do in I++, but you do it on all of these iterations, so you have just put it in the end over here. Then you have your nums of I is equal to current and the other constraints, and you know how this is working. I'm so sleepy, my goodness.